Hello everyone, welcome to AI Anytime channel. In this video, we are going to see how we can use newly released multimodal model named Qwen2 VL and 2B instruct model to basically fetch information from video files. So for example, if you want to build chat with video, or if you want to find out information from video files, how we can use this model. Now that's the agenda of this video. I already have created a video on Qwen2 VL, which is vision language, and 2B. So the model is released in two different weights variant. One is 2 and the other is 7 billion parameters. Now already have created the video for text and image, that how you can perform like OCR and extract information with high quality outputs previously in my video. Now in this video we're gonna keep it very short and only focus on the chat with video or find out information from a video file. Okay, now that's what we're gonna do here. So if you look at here on my screen, I already have installed. Now Qwen, you have to build transformers from source. So I'm just installing it from GitHub for the support, and then we have accelerate and flash attention. So I'm using L4 GPU. You can use A100, A40, L4, and any other GPUs that you have, depending on which model that you want to inference. If you want to inference 2B or if you want to inference 7B. Now I am also using Qwen VL utils that will help us with some utility modules for Qwen vision language model, and AV is required for video processing, with for basically retrieving information from or fetching information from video rather. Now I already have a file here that's called vidmp4. That's the file I'm gonna use. It's basically different use cases, guys. You can solve different use cases with this. For example, if you want to uh, build a chat with video where the students can come and understand about surgery that is happening, some surgical tools that is happening, mainly in the medical space. Now you can build it to explain product demo, right? You have CCTV cameras, for example, and if you want to automatically let Qwen model to tell you how to set that up, how you can set up that product, how you can install that, different use cases that we can solve with this model. So if you look at here, this is the video that I have.
The next steps include allowing the ChloroPrep to dry. Following that, I'll mark the skewer. Next, I'll use an Ioban dressing to seal in the knee completely.
So you can see that was the video that I have taken as a sample, and I'm going to ask some questions, and I'm thinking that Qwen should answer those questions. That's what I want right now. If you scroll down, let's import. This is where the Qwen model is. Qwen is built by Alibaba Cloud. Okay, this model. So let's first get from transformers. So let me just get everything here. From transformers, import auto. We don't need auto model for causal LM because for that we're gonna use, for generating the text, we're gonna use Qwen2 VL. So let's do that. So I'm gonna use Qwen, and it should show me, but it's not showing. So let's just search for it. So Qwen2. Let me see, where do I find that? VL for conditional generation, and then we need auto tokenizer and we need auto processor. So let me just get auto processor over here, auto processor, and then we are good. Now the next thing is we're gonna have Qwen utils. So let me just do from, yeah, that is fine. Qwen, not processor. They have something called process vision info. You can see it over here. And then we need torch. So let me just get torch here. And 2B kind of also works on if they have quant model, guys, so quantized model, so you can also use that on T4, if you want, if you don't have enough compute, and if you want to use Google Colab. Now here I'm going to define the model name, so let's just copy this. It's not a gated repository, so do not have to log in with Hugging Face. Now you can see the model name that has been defined, so let's just get the model. So to model, and I'm going to use Qwen for conditional generation, and of course that from pre-trained. And now here I'm going to pass the model name. Firstly the model name, and then you pass the D type. So torch D type, torch B float 16, device map, auto, and then I'm going to also have, attention. Okay, so let's just use that. What attention implementation that we're going to have. So there are different types of attention implementation depending on what kind of GPU you have. So let me just have attention implementation. And in attention implementation, we're gonna use flash attention 2. If you don't have uh, adequate GPU or compatible GPU, you can also use HDPA as attention. So that's what I'm gonna use. So let me just do flash attention over here. I'm gonna use flash attention 2, and after that you have device map auto. That is fine. Let automatically decide. Uh, if you can also write CUDA if you have. Okay, and model name. Let's just run it. This will take a bit of time. Okay, so let's wait for it, and let's keep writing the next set of code, guys. So this will take a bit of time to load it, download it, and then load the model. So what I'm gonna do is processor, and then we're gonna use auto processor over here. So let's just use auto processor and auto processor dot from pre-trained. So I'm just gonna use from pre-trained, and here I'm going to pass the model name, and that's it. We don't need this for now, and just let's do processor auto processor dot from pre-train, and you can see we are good. Now we're gonna define like a simple system prompt kind of a thing. So let's what I'm gonna do is messages, and in messages what I'm gonna do is not this, it's a list, and here we're gonna have bunch of dictionaries and then key values pair. So the first is the role. So the role is of user. Let me just write user here. And once you write the role user, now you have to pass the content. So here you can pass image, you can pass text, you can pass video as well. So in the content, what I'm going to do is I'm going to pass my, excuse me, I don't know why this auto processor is coming. Okay. Now in content, I'm going to first pass the type. What is my type? Now here, if you have image, you have to pass image. Now here I have video. So I'm just going to pass type equals video. And here you can also define some of the other inference params. So in that case, you have, so let me just define video, and then you give the path of that video where you have saved the video. So for that, I have let's take the path from here. So just copy path, come here and paste, and that is done. Now you can also define the maximum pixels this is directly proportional to the computational speed or the computation that is required. So I'm going to have max pixel. It's a value that you can define. So let's keep it like 360 420 or something like that. Okay. And now I'm going to have frame per second. How many frames per second? So I want 1 frame per second and not a lot. Okay. Now these are the things that you can customize it. So you have role user. Okay. I have missed something. Okay. Now low. To this will entirely go inside this. I missed that. So let me just come here and paste. Excuse me, indentation. Okay, now this is good. So fine. And basically this becomes a payload, guys. So when you are working with some systems like AWS, some tools like AWS SageMaker, basically you can also, if you are using text generation inference TZI, or because they use deep learning containers DLC on SageMaker, they basically dump your entire JSON. So it's good practice to always follow the way we defined JSON, because when they do the dumps, some of the systems might give you error if you haven't defined that in the right order. Now here I'm going to have type. Now in type, here you pass the text, and in this text you're going to define your question. So what do you want to get from this, right? So here let's define the text, my prompt. Basically this is the prompt. Now I'm going to say why did the or let's first ask, explain the video. Can you explain the video in brief? Okay, so this is my question, and this is what we're going to do now. Now we have our messages, so let's just run this. And you can see we ran our messages. Now if you just print messages, it will show you whatever you have configured for messages. Now we're gonna apply some chat template for this. So let's just do that. So what I'm gonna do is text equals, and then just do processor dot apply chat template. Ah, I'm on Colab Pro, guys. They say that they are providing some you know code as code assistant and all, and this is extremely shit. Okay, I don't like Google products, to be really honest. Okay, text processor, anything, AI stack, their cloud, nothing. I'm not a huge fan of Google products. Text processor, and I'm gonna pass messages and tokenize equals false, and then add generation. See, it should suggest me by then. Okay, add generation prompt true, and let's just run this. Okay, now we have our text. Let me just, it will create an object. Okay, if you run the text, you can see it says you are a helpful AI assistant. It's basically a system prompt that we have. It says you are helpful you are a helpful assistant. Blah blah blah. Can you explain the video in brief? And basically formats it out in that format that we need. Now, what I'm gonna do is I'm gonna have image inputs. So let's have an image inputs, and then we also have a video inputs. Basically, when you say chat with video, right, it basically on the frames, guys. Extract all the frames and then you pass the frames. Okay. Process vision info, and then you're gonna pass the messages here. So let me just pass the messages. This is so pathetic. Okay. Messages, and then I'm going to define my inputs to use processor. So let's use processor here. So let me just use processor. And within processor, we're going to define our inference param. So text, and then goes within the list. So text, and that goes within the list, guys. Images will be nothing but your image inputs, and your videos will be your videos input. So that's going to do video inputs. So images, videos, what next? Let me just come down. Just videos, and then padding equals true. If you don't know about padding and all, I'll recommend you go and start from CNN and stuff to understand these fundamentals. Return tensors equal, it's a PyTorch tensor, so we're gonna have PT. So return tensors, and then we are good. Now our inputs, now what I'm gonna do is upload this to CUDA device. So basically leverage the GPU for faster computation, and inputs to CUDA. Now I'm gonna generate the ID, excuse me. So let's generate the ID, generated IDs. This is the ID, and then I'm gonna do model.generate. And in model.generate, I'm going to pass some inputs, and model.inputs, and then pass max new tokens 512. Like you can keep it higher if you want a higher max new tokens, but this is fine for now. So this is going to generate IDs, a numerical representation. So let me just do generated ID here to show you what I mean. Generated IDs, and then you can see the tensors value. Now we're going to trim this. So let me just do generated IDs underscore trimmed, and I'm gonna trim this. So excuse me. So what I'm gonna do is output IDs. Let's create a variable. So here out IDs, and in output IDs, I'm gonna have length of my input IDs. So in input IDs, output IDs, and then for in IDs, and that's why we're gonna zip it around. So we're gonna zip this for in IDs and out IDs, and in zip. And what we're gonna zip is we're gonna zip the input.input IDs and the generated IDs. It's so pathetic, it's not showing me at all. I'm not happy. Input IDs. Yeah, input dot inputs ID, not inputs. inputs.input ID. That's what we have defined. That's what we're going to define. Input.input ID and IDs, and then your generated IDs. That's what we're going to do here, guys. So now let's just run this. Okay, and now you can see there's a different. Now generated IDs. What we're gonna do is we're gonna get the output text now. So we're gonna use decode, batch decode. So let's just do that. Output text, and how we're gonna use processor. We're gonna use processor dot batch decode. Processor dot batch decode, and in this batch decode, I'm gonna pass my generated IDs. So basically, first we do the tokenization, and then we do a de-tokenization. We decode that generated ID streamed and skip special tokens, skip special tokens true, and then pass your once there's something called cleanup tokenization space. So let's make that false. Pathetic. I'll recommend you use run pod and all those things, guys, rather than using Google Colab. If you want, don't take Pro for free. It's good. Spaces, cleanup tokenization spaces, and I'm gonna do false. And now let's print the output text. And you can see, I'll show you here. That's the output. It says the video shows a group of medical professionals. Let me make it here. Performing a surgery on a patient. They are wearing protective gear and working together to perform the procedure. Intricate details of the operation, including the instruments and tool, blah, blah, blah. Let me ask this question. One more question. Why did why did the doctor mark the knee area? So if you look at the video, doctor has marked on top of the knees, probably for you know uh, find out the spot for the surgery, where basically just to make sure that's the incision, that's where the incision that's they're gonna do. The doctor marked the knee area to ensure precise placements of the surgical instruments and to guide the procedure during the surgery. This is a common practice in surgeries, especially when using advanced equipment like laparoscopic surgery or robotic surgery, where precision movements and alignment are crucial for the success of the operation. Fantastic response. I liked it. Now, that's what it is, guys. You can take other use cases. You can build something else as well. Different use cases you can solve. You can build a Gradio application if you want. If you go to here, right, I'll show you. If you go to these spaces, you can learn from these spaces. If you are struggling somewhere, if you are the code snippet, you can see this is how you can build. How you can build, go to the files, app.py, look at how they have built it. So you can also build something like this, right? But these are more comprehensive, pretty similar, but they have to build, like you have to build this modular, you have to create functions and all to basically use this in a Gradio application. So you can also do that. I'll recommend you do it. Solve complex use cases. Also coming up with a fine-tuning video guys on Qwen2 VL pretty soon. So stay tuned for that video. Now this code will be available on my GitHub repository. If you have any question, thoughts, or feedbacks, let me know in the comment box. If you like the video, please hit the like icon. If you haven't subscribed the channel yet, please do subscribe the channel. That motivates me to create more such videos. That's all for this video, guys. Thank you so much for watching. See you in the next one.